In this recording, we'll work another example. What we have here, we have a charge of -3 microcoulombs at location A. And we are interested in the force that it's going to experience. Notice that we have 3 other charges close to charge A. That means that each one of these charges is going to exert a force on it. This charge, and that charge. Okay, now let's label them so we can use the same labeling like we did last time. I'm going to label this one B, C, and D. First thing we are going to do is use Coulomb's law. If you recall, we said the absolute value of F, or the magnitude of F, is K Q1 Q2 over R squared. So we are going to use that for each one of them. So the first force, we are going to calculate the force exerted by B on A. So that's going to be equal to 9×10⁹ Newton meter squared per Coulomb squared times the charge of B, which is in this case, I'm using the absolute value, 7 microcoulombs that's times the charge of A, which is -3 microcoulombs over the distance separating them squared, and the distance separating them squared is 4 meters. Okay, it's given that. So over 4 meters squared. Okay, and we calculate that. Okay, so what we have is 7 times 3, that's 21. 21 divided by 4 squared, that's 21 divided by 16. Times 9. That's 9×10⁹. So that gives us 11.8. And then we have 10⁹, and then 10⁻²², so 10⁻3. So let's just say millinewtons. So not to have to carry that 10⁻3. Okay, now continue. Force that's D, I'll do the easier one first. D exerts on A. Same kind of expression. 9×10⁹ Newton meter squared per Coulomb squared times, now we are going to have 2×10⁻⁶ coulombs times -3×10⁻⁶ coulombs over 6 meters squared in this case, and that should be equal, we calculate it, 2 times 3 is 6, 6 over 36 is 1/6, so we are left with 9/6, so that's 1.5, so that gives us 1.5 10⁻³ newtons, or 1.5 millinewtons. It's a much smaller force because we have a smaller charge and a larger distance. Now, the last one we have to calculate is not that complex, except we have to find the distance r. This is my distance r. Okay, my distance r, I can find it using the Pythagorean theorem. So I have r squared is going to be equal 4 meters squared plus 6 meters squared. Okay, so 6 squared, that's 36, plus 4 squared, that's 16. So we need to find square root of 52, which is 7.2 meters. So R is 7.2 meters. Okay, and then let's see. Actually, we didn't need to take the square root because we are trying to find r squared anyway. So F CA is going to be equal to 9 10 to the 9. Because of space limitations here, I'm not going to write the units. Just forgive me for that. So I'm going to have 3.5 10 to the minus 6 times 3 10 to the minus 6. Of course, it's minus 3, but we are doing the absolute value over the r squared, which is 52 meters squared. Okay, so here that gives us 3.5 times 3 over 52. So that gives us overall 1.8 millinewtons. Okay, so our answers are 1.8 millinewtons, 1.5 millinewtons, and 11.8 millinewtons. Okay, before moving on, just let's calculate one more thing. We are going to continue this in the next screen. I prepared another screen for this, so we'll not have to be erasing like we did in the last recording. Okay, let's try to find this angle here. It can be any angle, but let's find one of them. Let's say this. So 4 meters, and then the opposite is 4 meters, and the adjacent is 6 meters. So 4 over 6. And then we do the inverse tangent of 4 over 6. That gives us this 33.7 degrees. Okay, we'll carry that information to the next screen. Okay, let's see. We said FBA. Let me write them all. FDA and FCA. This is 1.8 millinewtons, 1.5 millinewtons, and the other one is 11.8 millinewtons. And then the angle, we found that this angle to be 33.7 degrees. Okay, let's add our forces. Remember, our overall force is going to be FBA plus FDA plus FCA. And again, we are going to put them in a table. Let me use more space this time. Okay. This is the X component, this is the Y component, and then FBA, FDA, and then FCA, and here I'm going to have my overall force. Okay, now the diagram. I probably used up a little bit space that I should not have, but let me change the color so I can get around that. Okay, FBA, that's the force exerted by B on A. Now they are both of the same sign, so it's going to be a repulsive force, and that force then is going to point like this. Okay, so it's along the line joining the forces, but it's repulsive. So it is being pushed away. That's why it's pointed that way. Now, the same thing for FDA. FDA is along the direction joining D to A, but it is repulsive because they have the same sign, so it should look like this. And then FCA, they are opposite sign, so which means that the force has to be attractive, so it has to point this way. Okay. These are my three forces. We calculated this angle as 33.7 degrees. So we are somewhat ready. I'm going to change the colors to blue for a second. Okay, if I take this as my x-axis and this as my y-axis. Now, I'm going to try to find for each one of these the x and y components. You notice that FBA is along the y, so its x component is 0. FDA is along the x, so its y component is 0. That makes it easy. FBA is along the positive direction of the y, so it's going to be fully there, 11.8 millinewtons. FDA is along the x, but it's in the negative direction, so it's minus 1.5 millinewtons. Now, FCA is the one that requires a little work. So let me, anyway, just for the fun of it, let me use colors. Now, this is going to be my FCAX, and this is going to be my FCAY. Now, FCAX is going to be 1.8 millinewtons times cosine of 33.7, 1.5 millinewtons. Now that looks like it's going to make life easier for us. For the y component, it's going to be 1.8 millinewtons times sine of 33.7, but then we need a negative sign because it's pointing in the downward direction, so it's going to be minus. I'm doing the calculation on the side here, so that gives us minus 1.0 millinewtons. Okay, so here we have minus 1.5 plus 1.50, and here 11.8 minus 1, so that gives us 10.8 millinewtons. So we are lucky here, we don't have two components, so the magnitude of my force is 10.8 millinewtons, and its direction is along the y-axis, or theta for it is going to be 90 degrees. Okay, that's my force.